Now, I sincerely hope that in the preceding videos I didn't get carried away and say that the graphs actually have these shapes, but I might have, because there are graphs associated with this that have these shapes, and I wasn't thinking deeply when I did that last video. Now, the points I made are all correct, all the points about constructions and analysis and numerical information and symbolic analysis. However, the graphs, this graph cannot have this shape, and this graph appears to maybe have an asymptote with the negative y-axis. So I'm saying this graph might not have the shape that's indicated here. It certainly doesn't have an asymptote with the negative y-axis, for the simple reason that this is a power of f prime versus a power of f, and negative powers, as you know, are certainly possible. You get a negative power of f anytime the y factor is less than 1. And y factor can certainly be less than 1, gives you a graph that has this kind of shape, and that would be a negative power, that would be associated with a negative power of f. Unless this graph is conceived to cross the y-axis into the negative powers and to extend to any possible negative power, it's not going to have this specific shape. Doesn't mean it doesn't have an asymptote, doesn't mean it wouldn't have a slant asymptote, but it certainly will not have a vertical asymptote. Now, this graph simply cannot have the shape that was indicated for this very simple reason that the y factor can't be negative. Y factor of a graph can't be negative. The y factor is the factor by which you multiply. Well, actually, yes, a graph could have a negative y factor, but if it did, your function would probably be undefined for a lot of values of x, and it certainly wouldn't be a power function. The reason being that if you multiply the y coordinate by a negative number, you're going to get a negative y coordinate the next time. Then you're going to get a positive, then a negative, then a positive, then a negative. And that creates a lot of complications when you try to generalize that to all values of the function. You don't have anything that remotely looks like a smooth curve, and you also would have the situation where you have a positive value here, okay, but then that positive value should be equal to the y factor times the value here. And if the value here was positive, this could be negative, and, well, that's not in itself a contradiction, but that does lead to contradiction when you consider extending the graph to all real numbers. Not something you got to worry a lot about. Just let's say that none of this is defined for a negative y factor. So this y factor can't go negative, at least not for power functions. And I believe not for any continuous function. I haven't proved that, but it seems pretty clear. So the graph might have this shape within a certain range, but it can't have this position because it can't cross the horizontal axis. So it's worth investigating what the actual curves would look like and answering the questions that we've indicated, but you are working within the constraints of my comments here.